Red Blue JD.
Thank you for coming at the sixth Arctalk of this semester. I'm sure more students will join us in a few minutes. Like always, they enter at the middle of the presentation, but we have to start. Today we welcome Jacob Schweiger and Josua Ishingwe. They are both research associates at the IFEU since 2017. Jacob holds a Master of Science in Energy Efficient and Sustainable Buildings and a Bachelor of Engineering. Instead, Joshua works as civil engineer at AC Consultants since 2016, and he holds a Bachelor of Engineering Building and Construction Technologies from UR, University of Rwanda. So today they will talk about low energy and comfortable buildings in Rwanda, which is a topic that concerns a lot, not only the students, but the architects that are going to design buildings for these specific climates and with the locally available materials. So I think that it's going to be very useful for you to listen, and if you have any questions, as always, the presentation will probably last around 30-40 minutes, and then we have the 20 minutes for question and answer at the end of the presentation. Thank you very much and welcome.
Okay, thank you for welcome. We are going to speak about this topic as they told, which is called low energy while keeping our house comfortable in Rwanda. My name, I will not repeat it again. I'm Joshua. This is Jacob. We are party of rapid planning. We are researchers, and this is our topic. Rapid planning is usually working in 4 cities. They choose 4 cities in the whole world. They are Frankfurt in Germany, Asyut in Egypt, and Da Nang in Vietnam, and Kigali where we are. And this is a special team for Kigali for rapid planning. I'm here, Joshua, and this Jacob, and those other guys, Lemmy, and this is Lemmy, and this is Michel, and another one who is called Leonard. We are all together working for that city of Kigali in that research. Overview of our presentation is we speak also in indoor comfort climate, comfortable residential buildings, schoolhouse, office, and so on. The goal of rapid planning, the goal of this presentation is to create curiosity for you just for climatic engineering. You will know what is climatic engineering. The definition of climate. The climate, you know, I think you have studied it like in high schools. Climate is like the statistic for the weather component, but for the weather component you see the temperature, humidity, wind, precipitation, and so on. While weather is for the short term. In classification of climate, they classify it according to size. Like here we did it. You can classify climate looking on size, on how about the study area. For example, there is microclimate, which goes on millimeters until 100 meters. There is mesoclimate, which divided in a climate of local location like 100 meters to kilometer. It goes until 100 kilometers. And macroclimate, which is main climate, zone climate, and global climate, they all goes based on the size of the study area. Another categorization of climate is by looking on the location. And we take a macroclimate and we divided into the location. Like you see, the cool one, which is higher a bit on polar zone, which is on the polar, like in those countries which are on the pole. There is temperate climate. You see, I don't know if you will look, like cool climate is start like here, near this tropic, and it goes around to the polar. And there's a temperate climate, like in those countries, like in Europe, continue Russia, and so on. There is desert. You see that one in an orange color, where we have desert. There's that climate of desert, and you have subtropics. Those one near the equator, and you have the tropics one down there. We start now our climatic engineering. We are going first to speak as the history of climatic engineering. You know, like in 100 years ago, they didn't have house like we have, but they was adapting themselves how they can live according to the disasters or challenge they had, according to the environment they had. Like an example on the cool climate we saw before, there above on the polar, we have the Iglo peoples there who live at the pole. You know that place is too cold. Like they can have like minus 30 degrees Celsius for cold. And here in Rwanda we can't have it. But they was adopting how they can live on that climate, and they were surviving it. They was building house like those one, you see, in an oval shape. And that house was serving that, and that house is built in the ice. Because you can't find soil. The whole area is covered by ice. They was building with ice, and they make it over. The oval shape helped the inside party to not lose the temperature too much. And they was heating inside. They was burning some stuff like bones for fish, and they keep the house somehow hot inside, and it doesn't lose that heat during other time. We have in temperate, we've taken one example for each climate. Like in temperate, we take Switzerland, a country in Europe, where they have temperate climate, and you build a house. You see, like in this party in the red, here is where people are living. But this party, it was serving? It was serving as the shade for keeping because the sun is shining too much. When it shines, they was keeping as a shade, and it serve when it goes like the night, the house will not lose too much heat. They was designing that way. We have another country, Italy, which is in temperate, because at that place, when the sun shines, it's very, very, very high. And they designed those houses like a veranda where someone can pass when it is too much shining. Like everybody who is building on the road, he reserves some part like a veranda. And you see some curtain here around those pillars, those columns. Those curtains, sometimes they close it just to keep a shade inside those corridors so that someone can pass because it was too hot. We come now on desert. Desert are usually found there near the corner of Africa. They was building those towers called the wind tower. They keep it open so that when the wind blow, and they was putting like in a 15-meter high so that the wind is somehow cool and doesn't have too much sand like impurity. And that wind was blowing, and it entered directly through that tower, and it goes into the house, and it remove hot air, and because it is too hot, that wind is hot, it remove hot air, and the house in that way is taking somehow refreshment. And they was designing to make it responsive to the environment they had, because they had too much temperature at desert. In the subtropics, you see, like in China where their climate is very humid and somehow hot. It's hot when the sun shines, like in day hours, it is too hot and somehow have some humidity. They was building very light construction with overhang roof, so that you see, like this house is built like a stadium. They was putting some empty space inside the house just for the easier movement of the air going through those windows, to remove humidity one and to remove also the high temperature. They was also adapting to their climate in that way. We come in tropics and you have a case in Rwanda. Like you see that house for the king, it was built, and they was having, like here in Rwanda, you see, they was having a cold night and a hot day. Like that house was serving to keep the king. In the night he was keep the warm, and on the day he was protecting him as a shelter for the sun. Here is a small other thatched roof where they was building here also in Rwanda. And when you try to ask, because some are from Rwanda, you say that people say that those houses was more comfortable and they was enjoying it, those houses, even if we had a project of eradication of Nyakatsi, but they was somehow comfortable. And what I can say about that history is that they was all resolving their problem they had according to the disaster they was managing. And here this picture shows us the building of nowadays. This is the Kigali city you see. We have office, schools, shopping centers, multi-story building, hotel, hospitals, and we found that most of those houses, they need air conditioning system just to keep their indoor comfort, while the other, for the ancient people, they didn't get those air conditioning. For our research is based on that history. Why the ancient people, they didn't have those air conditioning, and now for us we need it. And this is the question you must ask yourself as people which is studying architecture, because you will be the one who will be designing the building for the future. And I think at the end of this lecture, you will be knowing or having some knowledge or some curiosity as you want to do your research and improve on what we did. Now I invite my friend Jacob. He's going to speak more about the research we did in calculation, in mathematics, and how we did it. Thank you, Jacob. You are welcome. Thank you.
Red Blue JD.